Today I will talk about our efforts on stress testing BigBlueButton and seeing how far we can get and the bottlenecks, things like that. So in this presentation, I'll cover the motivation for stress testing, the key differences between BigBlueButton 2 and 3.0, an overview of the test, the technologies we use, and things like that. The details of the test, because as we are joining with multiple browsers, I want to describe what these browsers are doing. The metrics that we are collecting, which are very basic metrics. I believe we can create much more metrics and get even better results for next rounds of stress test, but it's a beginning. And also I'm going to present the tests with 100, 200, 300, up to 700 users with 3 different types of servers. I'm also going to show you example screenshots, showing you the level of information we can get when something fails, how we can debug and things like that, and also the conclusions we can take from these results. So the motivation for running the stress tests is mainly because with the new architecture of BigBlueButton, we moved most of the processing to the server. In BigBlueButton 2, information was forwarded to browsers, and browsers were merging this information and making it useful to be displayed for the users. But scaling BigBlueButton in BigBlueButton 2 was difficult, mainly because of the client performance. And here I added a topic saying about the hybrid classrooms. So one usage that we see for BigBlueButton is using it as a complementary technology in a lecture hall for hybrid classrooms. And this means that the users will be joining from the phone. And when you join us with a phone and there are 500 users or something like that, it's probably difficult to run it in BigBlueButton 2.0 because there is too much logic on the client side. So as we moved lots of logic to the server side, we want to be sure that we are at least we support at least the number of users that we support into 7, but we believe we can go for higher numbers. So this is the motivation for this work. The key differences from BigBlueButton 2.0, I already spoke a little bit about it, but let me be sure that I cover everything. So the browser resource usage in BigBlueButton 3.0, it's supposed to regardless of the number of users. User information updates. An example is if you are in a meeting with 100 users, no matter if you are showing the user list or not, in BigBlueButton 2.0, you will get the information of the users that are joining the meeting. In BigBlueButton 3.0, if the user list is closed, you don't get anything. Your WebSocket does not receive anything. So it's much better in terms of traffic, data consumption, and things like that. So this is a big difference. And of course, the server must filter more things, but it's still very good for the performance because you can be on a bus, on a train, and your traffic can be limited. So if we can save information, it's a good thing. And also the scalability, because Meteor, the technology we was relying in BigBlueButton 2, is limited to 1 CPU core. Over the years, we could work around it by starting several Meteor servers and things like that. But it was this scalability had some limitations, and with the new approach, we don't have limitation on the number of CPU cores that the server components will be using. So it's a good thing as well. Okay, so now I will explain a little bit, give an overview of how the test happens. So for the clients, we are using AWS Lambda running Chromes with 2 GB memory. This means that these Chrome browsers have only one CPU core. So it's still several users joining. It can run BigBlueButton, but as we can see later, some numbers like the time to join takes a little bit more time here than when we try in our computers, because Lambda is only with one core. So this is a limitation, but this is what is allowing us to run several users at the same time with a reduced cost. So it's still a good thing. And for the servers, we are running virtual machines hosted in DigitalOcean. The steps when we start a test are, first we clean up everything. So when we execute a new test, it does an SSH in the server, it stops BigBlueButton, clean up and optimize the database, remove all the journalCTL logs, and reboots the server. This is to make sure that by running one test after other, we're not leaving things that could compromise the performance. So we always start fresh. And during the execution, so after the reboot, the test will launch user 001, wait 30 seconds, because we want to make sure that this is the first client to join. When we call, when we make an API call to AWS Lambda, it can take a little bit of time because it will start a container to execute your function. So that's why we wait for 30 seconds. And after user 1 joins, we start launching in batches of 8 users. So we launch 8 users, wait for 5 seconds, launch 8 users. This is just to keep the traffic increased in the server, because if we were to join everyone at the same time, it's even better performance. But the reality is that not all users are going to join at the same time. So we are trying to simulate a real world usage here. And after the test completes, we download the journalCTL logs. Also, to be mentioned that every of these clients are taking screenshots. It's in this slide. So the other users that are joining will join the meeting and take one screenshot every 10 seconds. They also join audio as listen only, and they wait for the whiteboard to be rendered. So if they join and they don't see the whiteboard, it's marked as fail. If it joins and see the whiteboard, it's marked as success. Also, we store the network log, which means all HTTP requests that are sent and the responses that are received are persisted in this file. We also store all the WebSocket messages that each client received. This is allowing us to discover like large payloads or things like that. So it's very useful. And also we store the console log and the error log. So any error that happens during the session, no matter if we are joining 500 users and one user failed, we can go there, inspect the WebSocket, see the console log, the error logs. So it's very useful for debugging. The metrics that we are collecting for this presentation, because we have several metrics and logs and things that we analyze on a daily basis, but for a presentation, I had to pick some numbers that I could transmit as information here. So the numbers I have chosen are the number of users that could join, how many joined in less than 10 seconds, how many joined in between 10 and 30 seconds, and in more than 30 seconds. We're also collecting the server load, memory and load average, and the total number of GraphQL connections. And this is interesting because if everything is fine, the browser will connect to BigBlueButton and stay connected until the end of the meeting. But if we see reconnections, it means that something is wrong. Data is not getting received by the browser, things like that. So the total number of GraphQL connections is the metric we are using to say it was a successful test or not. Because the join, a user can join, but let's say it gets stuck or not receiving information. So we want to measure if it happened. So this is the number that is allowing us to detect these situations. Okay, so here I started a moderate complexity test with 100 users. So 10 users joined in less than 10 seconds. And again, this number with real browsers is would probably be different because it's mainly because Lambda is a bit slow. So anyways, this is the number we have here. So less than 10 seconds, 10 users, between 10 and 30 seconds, 83, and more than 30 seconds, 7 users. Server load was fine, 8 cores, the load was 3, so very good. And the number of GraphQL connections, no problems here. 100 connections, 100 users. Here we had 1 reconnection, but I believe it was myself checking in the browser if it was working, because it was the first test. So this one is probably myself connecting there. But this test was very good. One information is that if you want to see the raw data associated with these results, you can see in this QR code that the CSV is downloadable for for others to analyze. So the results for 200 users, no surprises here. Also no reconnections. Load is under control. Everything is fine. 300 users, same thing. With an 8-core server, the full installation, no optimization. Just if you go and install BigBlueButton now, you can get 300 users run just fine in your server. Here with 400 users, I consider it is still okay because 13 users reconnected, but it's kind of the maximum users for 8 cores in the current state. After the presentation, in the next slides, I will discuss more about these results. And the 16 core servers, the 400 users was just fine, and 32 core servers, the same thing. So when we grow to 500 users in 8-core server, we can see lots of reconnections. So this is a no-go. So for 500 users in the current state, it's still in development, so no panic. We are pursuing much better numbers before the release. But with 500 users, if BigBlueButton would be released today, you would need a server larger than 8 cores to handle it. So it's because the number of reconnections that we had. And we can see also that the load average was 16 for an 8-core server. It means we are CPU bound in this test. 600 users. So here we have a weird result that we need to analyze more. The purpose of this presentation is to show the stress tests, but much more will happen after this test stress, like analyzing it and improving. But basically with 600 users, we can see lots of reconnections, but the curious fact is that it doesn't get better with a 32-core server. So we believe it's some limit, some configuration of concurrency or something like that we need to tweak. But anyways, it's because here we have a load average of 20 with 32 cores, should be okay. So we believe it's some configuration. It's work for after the presentation. So with 600 users, we had failures. With 700 users, same thing. So basically, I stopped the test with 700 users, and these are the results separated by number of users and type of servers. So here I'm showing example of a session with SUSEs, the kind of information that we have. So if we look here, we have the information that the test was a SUSEs. We have the time that the page was loaded, that the modal audio was shown, the time that the whiteboard was loaded, the time the chat could be focused, and things like that. So this is the information we have for a session that have success. Also, if you want to see this page, it's an HTML page. You can scan this QR code and see it. And here is an example of a session with error. So when an error happens, the success here gets false, and we get the detailed screenshots that allow us to understand what happened and fix it. So this is the current state of BigBlueButton, and we detected in a 700 sessions, we detected one session that failed with this error. So what we do is we collect this folder and send to our development team, and they check what happened, what could cause the problem. With all this information that I told you, the WebSocket logs, the console logs, the error logs, this makes the developer's life much easier. So, and here is an example of a reconnection. So as I told before, we had some reconnections when the server was in high load, and this is a screenshot showing it how the user would perceive this reconnection. And still about the reconnection. So we are saying that if the user had one reconnection, it's a bad thing, and you should not use that number of users. If you try to run BigBlueButton in the current state with more users, it will probably work just fine, but we are pursuing the perfection here. So when we say 400 users in a server like that is good, it's perfect. It's not reconnecting, no delays and things like that. So this is important because we are really measuring things here, and we are looking for 100% quality sessions for the users. So the conclusions are that BigBlueButton 3.0 support 400 users in an 8-core machine. The official number for 2.7 is 250 users, so it's a higher number. 500 users in a 16-core machine. There is some bottleneck causing reconnections with 600 users. And I say it because the results were almost the same for 16 cores and 32 cores. So it's probably not limited by the server, but something else. So this is something we need to investigate. And as I already spoke, we are pursuing a higher number of users by finding and destroying bottlenecks. So we want to make sure we support large classrooms, and we are working very hard to make it happen. And we also discovered that running tests with hundreds of users repeatedly can be costly. So if you want to help us running the stress tests, if you have like several servers and machines or something like that, please contact us on bbperformance@imdt.com.br, and we can check how we can collaborate, because running these tests is the key to make sure we will, when we release BigBlueButton 3.0, it will be stable and we will work great in any scenario. So feel free to contact us, and we can find out how we can collaborate on making this become true. Yeah, that's it. I'm open for questions, and thank you all for watching this presentation. Hey George, the memory was the default in DigitalOcean. So for 8 cores, it's 16 giga. For 16 cores, I think it's 32 giga. And for 32 cores, I think it's 64. Maybe Anton can confirm these numbers, but I think that this is the memory. But if we look about memory, in any tests, the memory was a limiting factor, as you can see here. We are mostly CPU bound in these tests. We could say 16 giga is fine. Yes, this is another good test that we can do for another conference. Sorry if I tell your name wrong, but I will try Soheb or something. Soheb Somani. So yeah, BigBlueButton 3.0, when we release, why I'm saying when we release, because there are some things that we are investigating, like high memory usage in the client side and things like that, but these are bugs and we will fix. But by design, BigBlueButton 3.0 will use less resources in the device, because if you are watching a classroom, it's only going to consume what is used for watching the classroom. So before, you was receiving lots of information that should not be sent to the participants of a classroom. It will probably improve the performance on the client side. It's something we will measure before the releasing, and probably make a presentation as well. Oh yes, Jan, we can run the tests against your servers. It would be a pleasure. Uh, just to be noted that we have some limitations on the costs we can cover on because running AWS Lambdas are not free. But yeah, we can arrange. If you don't mind, please send me an email to BBB Performance and tell us you would like to stress test your servers and things like that, and we can find out a way to make this happen. Steve, this is a wonderful question. These tests are all in the same BBB session. Would it differ if many smaller sessions? By design, of course, we need to experiment to tell you with 100% sure, but by design, it should not matter, because the server does what is called multiplexing of the queries. So we have almost 55 queries that are running constantly to monitor the state of the meeting. And no matter how many different meetings are running, all this data is multiplexed together in the same queries. So it should not impact the performance if we have 500 users in one room or 5 rooms of 100 users. Yes, so have so many. You asked here if the user have a bad connection, if it would be better in BBB 3.0. Absolutely, because before, if you were in a meeting and a user was joining or leaving, you was getting information. This was overloading your connection. With BBB 3.0, it will not happen, because it's only getting information of what is displayed in your machine. So if you are a participant of a meeting and you don't have the user list displayed, you will get only the updates on the whiteboard and the state of the meeting that are much lighter. So yeah, it will improve the performance in these situations. Yes, Timo, I agree with you that LiveKit will help also. But one thing to consider is that with the WebSocket getting flooded with several messages, it gets to a point that the server should disconnect the user, and this could cause problems in the meeting. So the media is by design tolerant to fluctuating internet or something like that because of the packet dropping. But with the data, there is no packet dropping in the data. So if we are sending too much data and the client cannot handle this data fast enough, the connection will be dropped. So yeah, I agree that LiveKit will improve, but by design, media is tolerant to saturated internet, but data is not. So that's why BBB 3.0 will be really useful for this situation.
Thank you very much, Tiago. Just I have two other questions, if you don't mind.
Yeah, go ahead.
One would be, maybe you said it and I just didn't catch it. When you had 400 users, I think you basically for most of the users it took longer than 10 seconds to join, right?
Mm-hmm.
Yeah. Why is that?
It's my guess is because even with 100 users, we have a large number of users in this situation. I believe it's because the Chrome that is running within AWS Lambda is limited to one core, so it's slow. So when it downloads the client, it need to uncompress the JavaScript to parse and to load. So probably the issue is more on the client side than on the server side.
Oh, okay. Just the way the bots are joining.
Yeah, I'm happy. Ian said here that he will be able to have not only the servers but also the clients. So maybe, yeah, if we can cooperate with Ian to simulate the clients with powerful machines and against servers that are also powerful, it will we can re-execute this test and see how much it improves.
Yeah. By the
Because
way, I think we can
the
also
Lambda CPU is a limitation. Yeah. Sorry,
yeah.
Timo.
Yeah. No, yeah, okay. I think we could also, like VMs for clients, we could donate, so to speak, if you need that. But maybe we should have a group where we discuss what is needed technically for that. Maybe we can still find other people.
Okay, sure. That would be great. If you don't mind, if you can contact us on this email and send your idea, it's great. Yes, yeah, on 2.7, a single session is tied to a single node. Yeah, that's it. So with 3.0, we can handle large meetings. Yeah, you're right. Cool. Yes, the test suite is open. I made a presentation on the previous BigBlueButton summit when I showed it, and also there is the link for the GitHub and things like that. But please, if you want to cooperate on this test, you can send an email here, and I can make sure I can. We can also make a meeting, and I can help you configuring it and getting it running. So don't get limited by what is in GitHub, because sometimes we commit stuff there and we're not sure, because it's not like the BigBlueButton that we are testing and blah blah. This is more like a repository where I am committing the tools that I am using. So maybe if you want our onboarding on this repository and some help, we can schedule a meeting and we can run the first tests together. So it will be a pleasure. Okay, I think our time is over. I will be available in GitHub or on the mailing list, but also in this email address. So feel free to contact me. And thank you again for joining.
Thank you very much, Tiago, for this wonderful presentation and answering all the questions. Just an important note about the next session. The join button is not appearing for multiple people, so please use the link from the public chat that I just sent. We'll hijack the meeting for after that. So please join the testing session and we'll combine both of them. First, starting immediately, there will be the LTI presentation, and after that, the testing. Thank you all for joining, and thanks again, Tiago, for sharing all these stress testing results with us. Bye, everyone.